Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to see a log-log interaction model worked example. We've seen that in the log-log interaction model, elasticity is no longer constant, so let's make that concrete with numbers and interpret the coefficients carefully. Let's suppose that we have now estimated a model that looks like ln y equals to 1.5 plus 0.4 ln x plus 0.1 z plus 0.2 ln x times z. When we have the derivative of ln y with respect to ln x, as a reminder from the previous video, we had that it's equal to beta 1 plus beta 3z. So in this case, it is going to be simply 0.4 plus 0.2 z. So this is the elasticity of income with respect to education. So it's not a single number, as we see all over again. It's an actual expression, and it depends on the z variable, which we've called this the experience. If you refer back to the video that we did for the standard log-log model, where the elasticity was simply the beta 1, so it would have been just the 0.4, it was the same for everyone. But now, as you can see, it's going to vary for different levels of experience. So we can do some evaluations at different levels of experience. For instance, we can imagine z to be 0, 1, let's say, and 3. The elasticity of income, so assuming y is income with respect to education, it's going to be whatever value we get once we plug the z in the expression that we got for the partial derivative. So it will be 0.4 when z is equal to 0. It's going to be 0.6 when we've got z equal to 1, and it's going to be exactly 1 when we've got z equal to 3. So in terms of interpretations, what we can see in here is that the elasticity rises by 0.2. So the elasticity rises by 0.2 for every additional unit of experience. Okay. And that's where beta 3 is doing its work. An elasticity of 1 that we found here when z is equal to 3 means basically that education and income move proportionally, and a 1% increase in education is associated with a 1% increase in income for someone that has 3 years of experience, okay? Now, the beta 3 being equal to 0.2, again, is telling us that each additional unit of experience increases the elasticity of income with respect to education by that 0.2. So that means that beta 3 by itself is not the elasticity, so the 0.2 is not the actual elasticity, but it's the rate at which the elasticity changes with z, okay? You can do exactly the same exercise, but by flipping the interpretation. You can look at the derivative of ln of y with respect to z, where you will find that this is 0.1 plus 0.2 ln of x. And in here, the percentage effect of experience depends now on education, and you're going to do the usual interpretation that we just did for the opposite case. Okay, we won't be computing it in here. You can do it as an exercise for yourself, but keep in mind that the symmetry still applies even in this case, and both effects are heterogeneous. what are some of the common interpretation mistakes to avoid? The same ones that we saw with the general interaction model apply in here as well. So if someone says that the elasticity is the 0.4, that is not always correct. You'll find that 0.4, just as we found it here, when z is equal to 0. Okay, but in general, it's just going to be 0.4 plus 0.2 z. Okay, so always state the value of z you are evaluating at. In log-log interaction models, elasticity varies with the z, and the beta 3 is the rate of that variation. Thank you for watching this video, and stay tuned. I'll see you in the next one.